Human brains are highly specialized, but they evolved to understand a very specific, limited slice of reality. We are wired to process slow-moving, medium-sized objects operating right here on Earth. The actual universe operates on a completely different set of rules. Out there, the cosmos is governed by extreme velocities, violent collisions, and physics that break every earthly intuition you have. We only know about these bizarre mechanics because a relatively small group of researchers use insanely precise machines to measure the impossible. To truly understand how space, time, and matter behave, you have to be willing to abandon your common sense for the next few minutes. Let's start with a photon, a particle of light. If you could ride it through the vacuum of space at the speed of light, you would experience absolutely zero time. Because time effectively stops at that speed, the photon perceives its entire journey across the cosmos as a single frozen point. But if light moved to an absolute speed, what happens when it hits a dense medium like water or glass? We know it seems to slow down and bend. Here is an electromagnetic wave interacting with a field of atoms. As it passes through, it forces the surrounding atoms to vibrate along with it. Oscillating these atomic fields creates a time delay, without ever actually reducing the underlying speed of the original photon. So the light we measure slowing down on Earth is actually just a combination of the photon's raw, unyielding speed and the physical drag of the environment it pushes through. Our intuition about temperature is just as fragile. Consider the sun's corona, its outer atmosphere. It burns at a staggering 5 million degrees. Yet NASA launched the Parker Solar Probe to fly directly through that inferno at 400,000 miles per hour, and the spacecraft survives. It survives because of a quirk of physics. The particles in the corona are incredibly hot, meaning they vibrate with massive energy, but they are spread so far apart that they simply can't transfer enough heat to melt the metal probe. Watch how expanding space physically stretches a photon's wave as it travels. Shifting red, it loses energy. This leads to the universe's heat death. As every photon fades, space cools to absolute black, reaching a uniform temperature where no energy can be exchanged. That slow fade sits in stark contrast to the most violent events we can measure, the collision of black holes. In 2015, two black holes, each roughly 30 times the mass of our Sun, spiraled into one another. In just 0.2 of a second, the mass of two entire suns was converted into pure energy, briefly outshining every star in the observable universe. That blast of invisible energy traveled 1.4 billion light-years, physically rippling the fabric of spacetime like a cosmic tsunami. When that wave finally washed over Earth, it was captured by the LIGO facility. To prove this collision happened, LIGO's lasers had to measure a physical distortion in reality that was 1,000 times smaller than a single proton. Our entire planet was physically squeezed and stretched by a cosmic monster, and human beings only noticed because of a microscopic variation in a beam of light. So how does a single species manage to build the machines capable of measuring these bizarre paradoxes? Right now, the James Webb Space Telescope is looking back in time to the dawn of the universe, hunting for the very first massive, dark matter-infused pseudostars. You might expect this level of exploration to drain national treasuries, but NASA's entire science division operates on less than $6 billion a year. To put that in perspective, economists have pointed out that the global military apparatus likely spends more money just on air conditioning. Despite the low cost, for every dollar spent on these missions, studies estimate a return of 2 to 3 times that amount in economic advancement. By solving these engineering hurdles, we drive innovation that trickles down into every sector of modern life. But there is a cultural myth that stops young people from joining this pursuit: the idea that you have to be born a flawless genius to understand space. We hold up the solitary, natural genius as the archetype of physics, ignoring that modern science is a messy, deeply collaborative process. Astrophysicists like Michelle Thaler point out that science is exactly like a language. Mastering it requires grit, passion, and time, not immediate magical brilliance. Your curiosity and your persistence are the only prerequisites you need to participate in exploring the cosmos. The universe is strange, violent, and deeply counterintuitive, but it is ours to observe and map. Keep asking questions, hit subscribe, and as always, keep looking up.